Good afternoon, students. Today we are going to talk about manufacture of sulphuric acid by conduct process. And this is a simple diagram showing how this sulphuric acid is obtained. So, first you should know the raw materials that are required to produce sulphuric acid. And one of the raw materials needed are, we have oxygen, water, and sulfur oxide, which is obtained by burning sulfur in air. So the raw materials we have water, then sulfur oxide, then we have water, sulfur oxide, and oxygen. These are the raw materials that are required in the production of sulphuric acid. So, let's look at some of the procedures. Procedure 1, or at stage 1, we have burning of sulfur in air to form sulfur oxide. At this stage, sulfur is burned in air to form sulfur oxide, or you can also produce this sulfur oxide by heating a metal sulfide such as iron 2 sulfide. When you heat iron 2 sulfide in the presence of oxygen, you are going to form sulfur oxide and iron 3 oxide. This is what happens in this stage, or at stage 1, during the production of sulphuric acid. So at stage 2, here is at stage 2. At stage 2, this is what is going to happen: purification of sulfur oxide. At this stage, we have some purifier which are used to purify or to remove the dust particles that have passed from stage 1 going through stage 2. So at this stage, we have the purification. So we have some particles that are purified. Some of these particles that are purified, we have carbon, dust, have arsenic 3 oxide. Yes, we have arsenic 3 oxide, carbon, and dust. Maybe you can be asked in an exam, give examples of substances that are purified or substances that are removed at stage 2. So we have these substances are known as, can say, impurities that are removed. We have dust, arsenic 3 oxide. We have carbon. These are examples of impurities that are removed at this stage 2. And the reason as to why these impurities are removed is because these impurities are removed so as to prevent them from poisoning the catalyst. So the mixture is then dried by passing through concentrated sulphuric acid. The mixture is dried by passing through concentrated sulphuric acid. So let's move on. At stage 3, or in stage 3, here is the drying tower which I'm talking about. We have concentrated sulphuric acid in the drying tower, which is used to dry the mixture. Concentrated sulphuric acid at that point is used to dry the mixture. That is the function of that concentrated sulphuric acid. So at stage 3, the purified mixture of dry sulfur oxide and air is passed through a heat exchanger. This mixture of sulfur oxide, as you can see, sulfur oxide plus air is passed through the heat exchanger. The mixture is passed through the heat exchanger to acquire the optimum heat to facilitate the conversion of sulfur oxide to sulfur 6 oxide. This mixture is passed through the heat exchanger so as to facilitate the conversion of sulfur oxide to sulfur 6 oxide. To facilitate the conversion of sulfur oxide to sulfur 6 oxide. Then this mixture is then taken to the converter containing the catalyst. From the heat exchanger, now we are going towards the converter, and this converter contains a catalyst. The converter contains a catalyst. So another thing that we need to take note of, in the converter we have a certain equation that is going to take place, and the equation that is going to take place is the equation between sulfur oxide plus oxygen to form sulfur 6 oxide. That is a simple equation that you need to know. Here is at the converter, where we have sulfur oxide plus oxygen to give us sulfur 6 oxide. You must make sure that the equation is balanced, or else you can fail it, or you can even given a half a mark in that case. So from the converter, the catalyst, you should also take note of the catalyst that is going to be used at this point. So we have two catalysts that you can use. You have vanadium 5 oxide, then you have platinum. You can use either vanadium 5 oxide or platinum as the catalyst at this point, or in the converter you can use platinum catalyst or vanadium 5 oxide. Platinum catalyst or vanadium 5 oxide. So vanadium 5 oxide is preferred because it is less susceptible to poisoning. This vanadium 5 oxide, why is it that it is preferred? It is preferred because it is less susceptible to poisoning. It cannot be easily poisoned. Another thing that I've just forgotten to tell you, it is that when you write this equation, when you are asked to write this equation in an exam, you should take note that you must put here at this point the catalyst that you are using, which is vanadium 5 oxide. This is the chemical formula of vanadium 5 oxide, V2O5. V2O5. Then let's move at stage 4. And at stage 4, we have the conversion of sulfur 4 to sulphuric 6 acid. Not sulfur 4, sulfur 6 oxide to sulphuric 6 acid. At this stage 4, now we are converting. Here is at stage 4, whereby waste gases are going to be removed. These waste gases are just like the gases that are unreacted gases. The gases that have not reacted are going to be expelled out. Unreacted gases will be expelled out. So conversion of sulfur 6 oxide is passed through a heat exchanger to remove excess heat. They are passed at heat exchanger to remove excess heat. Then it is passed through absorption tower. Now we are here at the absorption tower, not at the heat exchanger. Sorry for that. At the absorption tower, we have this what is going to take place there. In the absorption tower, we have the dissolution of concentrated sulphuric 6 acid to form oleum. Here we are going to the dilution of concentrated sulphuric 6 acid is going to be diluted so as to form oleum. Oleum, the chemical formula of oleum is H2S2O7. The most likely question that you can be asked at that point is the equation that occurs at the absorption tower. So the equation that is going to occur at the absorption tower, let me write for you the equation. I have the absorption tower. So the equation at the absorption tower, we have said that sulphuric 6 acid plus sulfur 6 to form oleum, which is H2S2O7. That is the chemical formula of oleum. Oleum is H2S2O7. That is the equation that is going to occur at the absorption tower. You should take note of that. At the absorption tower, the most likely question, the first question is the equation that is going to take place. Then the second question, you can be asked to explain briefly what happens at the absorption tower. That one I've already talked about it. You can explain it. Then water is added to oleum to produce concentrated sulphuric 6 acid. That oleum, more water is added to form sulphuric 6 acid, and this is the equation that is taking place when you add water to oleum H2S2O7 shall form concentrated sulphuric 6 acid. Concentrated sulphuric 6 acid. This one usually occur in the concentrated sulphuric 6 acid. That is the equation. And well, that equation occurs at the dilution chamber. This is the equation at the dilution chamber. Dilution chamber. This equation of sulfur 6 oxide plus sulphuric 6 acid form oleum, it is the equation in the absorption tower. In that one for oleum and water, it is the equation that is taking place in the dilution chamber. That is the equation in the dilution chamber. So after there we have this is the concentrated one, sulphuric 6 acid that is formed is 98% pure. It is 98% pure. After there it is cooled, then transported in the storage tank, and that's all about a large scale manufacture of sulphuric 6 acid.